Hey guys, Miss Paraso here. So, in case you missed class or you need just a little bit of review about how to solve one-step, well actually not just one step, but any kind of inequalities, we want to remember that we do everything exactly the same as we do with equations. We're going to distribute, combine, collect, and use inverse operations to get that variable all by itself. The only difference is that if we divide or multiply both sides by a negative number, we have to flip the inequality sign when we're doing that. Okay, and then we're also going to graph our solutions. The open circle is if we have a less than or a greater than, and the closed circle is if we've got that equal to sign underneath to it. All right, so I'm going to walk you through the first three examples here and get you to pause the video and also check in with me every now and then. All right, so same steps. We're still going to draw in those railroad tracks, okay, except instead of an equal sign, it's an inequality sign. All right, I'm going to, again, goal is to isolate the variable, so I'm going to highlight my variable. And I can see that I'm subtracting 7. So add 7 to both sides. You want to show that balance. So that cancels out. We get x. Now, before I put my inequality sign, I'm going to do my math. Negative 10 and 7 is a negative 3. Now, before I write this, I want to ask myself, do I have to reverse the inequality sign? Well, take a look at the operation that you did to both sides. Was it multiplying or dividing? No? Then don't touch the inequality sign. Okay? All right, for your graph part, I usually take whatever this number is and I plop that number right smack dab in the middle. All right, that was a nice little bell to signify it's time for graphing. Okay, and then I'm going to fill in some numbers to the left and to the right. So that's negative 3, so that'll be negative 2, negative 1, 0. You don't have to fill the whole chart. Negative 4, negative 5, negative 6, negative 8. You can even skip lines if you want to, as long as you're staying consistent. Okay, so it's helpful when the variable's on the left, because if the variable's on the left, the way the inequality sign is facing is pointing down. So it's saying anything that's less than x is less than negative 3. So if I ask myself, is negative 2 less than negative 3? No. So I'm not going to go this way. And it's going to be an open circle on negative 3. Negative 3 is not a solution. But we want to show that we can get as close as we possibly can. So that's why we have an open circle. And x can be anything that's less than that. And less than is to the left. Less than is left. So there's our graph. Okay? All right, let's move on to number 2, railroad tracks. If you want to highlight your variable, it just draws your attention to what you're doing. I see that I'm multiplying by a negative 7, so I'm going to divide by a negative 7 to both sides. Those cancel out to equal 1, so that's just 1x. And again, before I write my inequality sign, I'm going to do my math over here. Oh, messy math off to the side. I can't do that in my head, so that's 2. Gives me 14, 6, bring down the 3, 63, 7 goes into 63 9 times, so that's it, so 29. And it's negative 29 because it was a negative number. All right, so before I put my inequality sign in there, I'm going to ask myself, do I have to reverse it? Did I divide or multiply both sides by a negative? Take a look at both sides. I'm dividing by a negative here, dividing by a negative here, so yes. So instead of greater than, I have to write less than. So that is my inequality sign. Okay. Graph it. We're going to put this number in the middle, negative 29. I'm going to skip 1, put negative 28 here, skip 1, negative 27. The lines are a little too close for my writing. Negative 29, skip 1, negative 30. Skip 1, negative 31. Okay, so it's going to be an open circle over negative 29. And should it go to the left or to the right? Good. It's pointing to the left. X is anything that's less than negative 29. Is negative 28 less than negative 29? Nope. So that means we have to go the other side. Go on this side. Okay. All right. Let's go ahead and check out number 3. These two were one steps. Gotta love the bell. Okay, those two were one-step equations. Now we see that we have two things happening. That's okay because we know what to do. We still put those railroad tracks in. Here's my variable. My variable happens to be on the right-hand side. I'm going to leave it there. All right, I'm multiplying by 4 and subtracting 3. Well, we get rid of the adding and subtracting first. So opposite, add 3. Add 3 to both sides. Positive 3 plus negative 1 is a positive 2. These cancel out to be 0, so this is just 4x. Now, before I put my inequality sign, did I multiply or divide by a negative? No. Okay, so I'm going to leave my inequality alone. Alrighty. And then here, okay, I'm going to divide both sides by 4. 4 divided by 4 is 1, so I get x. 2 divided by 4, don't tell me that it's 2. 2 divided by 4, that's 2/4. It's really 1/2. You can leave it as a simplified fraction. If your little heart desires to make it a decimal, go for it. Okay, again, before I write my inequality sign, did I divide or multiply by a negative? No, these numbers are not negatives, and it was division, but not a negative number. So it's going to stay the same. Now, here we need to pay attention. In the other two, our variable was on the left. We can read this still from the right. Wherever the variable is where you start, and you're going to have to read backwards here. So x, and it's opening up then. So x is greater than or equal to 1/2. So if we wanted to write it on the left, x, notice it's opening up to it 1/2. So if that helps you to see it by putting the variable on the left-hand side, you can, but don't do that till the very end. Because if we're doing flip-flopping with the inequality sign, we don't want to get that mixed up. Okay? All right, so let's take a look here. This is the number that we're going to put in the middle, 1/2. Okay, and all right, maybe then I'm going to go up to 1. Then this will be 1 and 1/2. And this is 0. So we go down to, we went up, I'm going by half, yeah. So this will be 0. This will be skip 1, negative 1/2. Okay. So I'm just counting by halves every other one kind of thing. So 1/2 and another 1/2, decrease 1/2, decrease 1/2. Okay? All right, so x is greater than or equal to 1/2. So that means because of that equal sign, we're going to color in the dot. And again, x is anything that is bigger. It's opening up. It's bigger than 1/2. So we're going to go up to the right. Okay? All right, so what I need you to do is... Okay, sorry about that. I accidentally hit my pause button before I gave you your instructions. Okay, what I want to take a look at, I want you to go ahead and try number 4. Pause the video and try number 4, and then check back in to compare it to my work. And then I think in number 5, I'm also going to have you come back and check in because there's some things I want to point out to you about certain things to keep in mind as you're solving these. All right, so at this time, go ahead and pause the video, complete number 4, then check back in to see how you did, and then we'll move on to number 5. Okay? Okay, check to see how you did with number 4. I highlighted my variable. Notice that subtraction sign belongs to the x, so if you cover that up, we see that it's a positive 12, so that's why I subtracted. And then when that moves, when that crosses out, notice that negative sign is still there, so you had to bring that down. Did you do that? And then negative 15 and negative 12 is a negative 27. So remember that this is really, there's a secret little invisible 1 right there, and we don't want any negative signs in front, so I divided both sides by negative 1. And you can see because I divided both sides by negative 1, that tells me I have to flip the inequality. So I flipped it to be less than or equal to. So go ahead and pause the video real quick in case you need to correct any of your math work. And then go ahead and try and graph it. All right, so hopefully you're paused and now you're coming back to check it out. So I set up my graph. 27 was in the middle. Put a couple numbers to the right and to the left. And x was anything going less than that, so it was colored in because of the equal to sign, and anything to the left. Right? Okay, go ahead and try number 5. Number 5. And that'll be the last one that I'm going to do with you for checking in. The rest will be up to you to finish on your own. All right, welcome back. Let's take a look at number 5. If you're not quite sure, you got stuck and you're just checking in to see if you're on the right track, let's go ahead and take a look at step by step. So highlighted my variable, railroad tracks in. +5 + 5. Should have solved it as that you got 2 is greater than or equal to 1/4 x. Remember, to get rid of a fraction, you're going to multiply both sides by the reciprocal. Okay, that'll help us cancel out on that side that has the fraction. And then, well, 4/1 is just like saying 4. So 4 times 2 and moving that way. Okay? All right, so that means when you're done, you get 8 on the left-hand side, x on the right. How do we read this? Okay, so again, start with a variable and read it backwards. So x, it's pointing to it, so that means that's the less than. X is less than or equal to 8. So if you wanted to rewrite that with the variable on the left, you can always just switch it and be like, okay, I'm going to put the x first, and then it's pointing to it, so I'm going to point to it, and now it's easier to see, oh, it is, x is less than or equal to 8. And that's going to help us with the graphing, okay? So there's my graph. Again, I started with 8, put a couple numbers to the right, a couple numbers to the left, colored it in because of the equal to sign, and it's anything that was less than, right? So do make sure that one of the things I want to check in with you about, and I thought one of these examples would be it, but for example, if you had something that's like this problem, and we've talked about this in class, okay, because the rule says to reverse the inequality sign if you're dividing both sides by a negative. Okay, well in this case, I would divide by 2, divide by 2. And sometimes what I get is that people are going to flip this because they're like, well, I have a negative over here. But that's not what that's telling you. It's saying if this is what you're doing, whatever you're doing to both sides, if you're dividing and this is the number that's being divided on both sides is negative, then you flip it. So this is wrong. So because we're not dividing by a negative, not into a negative, but by a negative, we won't flip it. So just be cautious of problems like that. It's if the number that you're dividing on both sides is negative, that is when you're going to flip the inequality symbol. All right, well, I think you got it from here. Go ahead and finish up the rest of these practice problems. I'll check in with you at class or post the answer key on Edmodo for you.